Integration of AI resource consumption metrics by Q2 2024. An overview. Introduction. The integration of AI resource consumption metrics is a pivotal initiative aimed at improving the efficiency and transparency of AI systems across various industries. Slated for completion by Q2 2024, this effort involves a substantial investment of $1.8 million to bolster data analytics infrastructure. This report outlines the structured four-phase development approach, anticipated challenges, key considerations, and the overall significance of this initiative. Overview of phases of development. The project is organized into four key phases, each vital for achieving the intended outcomes. 1. Planning and requirement analysis. The initial phase emphasizes the importance of understanding stakeholder needs and defining project scope. This involves comprehensive consultations with technical teams, management, and end users to identify the critical metrics required for assessing AI resource consumption. Key metrics include computational power, memory usage, and data processing speeds, which are essential for determining the operational efficiency of AI systems. 2. Infrastructure development. Following the planning phase, the focus shifts to developing a robust data analytics framework. This phase will utilize the allocated $1.8 million to upgrade necessary hardware and software, ensuring real-time processing and analysis capabilities. The development of this infrastructure is crucial for effective monitoring and management of AI resources across varied applications and industries. 3. Implementation of metrics. This phase involves the actual integration of the identified resource consumption metrics into existing systems. It includes deploying the relevant tools and methodologies that facilitate effective tracking and reporting mechanisms. The implementation process will also consider the integration challenges posed by legacy systems and aim for seamless operational continuity. 4. Monitoring and optimization. The final phase focuses on the ongoing evaluation of the collected metrics and the optimization of analytical tools. Establishing feedback loops will be essential for refining processes based on real-time data insights. This continuous improvement approach ensures that AI systems adapt efficiently to changing demands and operational contexts. Investment and infrastructure. The $1.8 million investment is pivotal for upgrading the data analytics infrastructure. This includes hardware, acquisition of advanced servers and storage solutions to handle large datasets generated by AI systems. Software, implementation of analytics tools that can process, visualize, and report on AI resource consumption metrics. Training, providing necessary training for personnel to leverage new technologies and methodologies effectively. The investment is structured to ensure that organizations can not only implement the metrics but also sustain their use for long-term efficiency gains. Key points across sources. Several critical themes emerge from the literature regarding the integration of AI resource consumption metrics. Data quality and bias. High-quality unbiased data is paramount for accurate metrics. Addressing potential biases in AI systems is vital for ensuring reliability and fairness in AI outputs. Use cases. Industries such as finance, healthcare, and manufacturing stand to benefit significantly from this initiative. For example, in finance, AI can enhance predictive analytics for risk assessment, while in healthcare it can improve diagnostic accuracy. Commonalities and differences in perspectives. While there is a consensus on the importance of integrating AI resource consumption metrics, differing viewpoints exist. Technical focus. Some sources emphasize the technical challenges involved in data integration and infrastructure development. Ethical considerations. Others highlight the need for transparency and accountability in AI systems, stressing that ethical considerations must parallel technical advancements. Timeline of events. Q4 2023, the project kicks off with initial planning and requirements gathering, setting the groundwork for future phases. Q1 2024, the infrastructure development phase begins with investments channeled into necessary technologies and system upgrades. Q2 2024, the implementation of metrics is rolled out with organizations starting to monitor AI resource consumption actively. Post Q2 2024, continuous monitoring and optimization processes will commence, focusing on refining data analytics capabilities and ensuring ongoing improvements in resource management. Conclusion: the integration of AI resource consumption metrics by Q2 2024 represents a significant advancement in the field of AI management. Through a structured four-phase approach supported by a substantial investment in data analytics infrastructure, organizations can enhance their operational efficiency and accountability. This initiative not only addresses technical challenges but also underscores the importance of ethical considerations in the deployment of AI technologies across various sectors. The success of this endeavor will likely set a precedent for future developments in AI resource management, paving the way for more informed decision-making and responsible AI deployment. The content presents several counterintuitive pieces of information regarding the integration of AI resource consumption metrics. 1. Investment in infrastructure versus immediate ROI. While the $1.8 million investment in data analytics infrastructure is substantial, it may seem counterintuitive to allocate such resources without immediate visible returns. Organizations often seek quick wins, yet this initiative emphasizes long-term efficiency and effectiveness over short-term gains, suggesting a strategic shift in how companies view AI investments. 2. Focus on data quality and bias. The emphasis on data quality and bias in the context of resource consumption metrics is noteworthy. It might be counterintuitive that improving metrics on resource utilization directly ties into addressing biases in AI outputs. Many might assume that resource metrics are purely technical. However, the ethical implications of data input and its influence on AI decision-making are equally critical. 3. Phased development approach. The structured four-phase approach could be seen as overly cautious or bureaucratic in fast-paced tech environments where rapid deployment is favored. Yet the phased strategy aims to ensure thoroughness and adaptation, indicating that a slower, more deliberate process can lead to better outcomes, countering the notion that speed is always paramount in tech advancements. 4. Industry application versatility. The mention of diverse industries such as finance, healthcare, and manufacturing leveraging these metrics might seem typical. However, it is counterintuitive that such disparate fields have a common need for resource consumption metrics. One might expect that the complexities and requirements of different industries would necessitate unique customized solutions, yet the initiative proposes a unified framework applicable across sectors. 5. Continuous monitoring as a norm. The final phase's focus on ongoing evaluation and optimization could be perceived as a burden, suggesting that initial implementations are insufficient. However, this perspective flips the conventional view that a completed project is static, promoting the idea that constant adaptation is essential for technological relevance, an approach that may not be intuitive in traditional project management paradigms. 6. Interplay of technical and ethical challenges. The distinct separation of technical aspects from ethical considerations in the integration process might initially seem logical. However, the recognition that both must be addressed simultaneously reveals a counterintuitive understanding that ethical concerns are not merely afterthoughts but integral to the technical framework's success and acceptance. These counterintuitive insights challenge conventional wisdom around resource allocation, project management, and the perception of AI's role in various sectors, emphasizing a more nuanced understanding of the integration of AI resource consumption metrics. Important content overlooked in the report. While the report on the integration of AI resource consumption metrics by Q2 2024 provides a clear framework and investment strategies, several nuanced elements are likely to be overlooked that hold significant implications for the success of the initiative. Here are key aspects that require deeper exploration. 1. Stakeholder engagement in planning phase. The report mentions stakeholder consultations in the planning and requirement analysis phase. but it does not elaborate on who these stakeholders are and how their input will be integrated into the project. The significance of this lies in the fact that different stakeholders, ranging from technical teams to end users, may have varying perspectives on what metrics are critical. Engaging diverse stakeholders can lead to a more comprehensive set of metrics that reflect real-world needs and challenges, thus enhancing the overall utility and acceptance of the metrics. 2. Real-time data analytics infrastructure. The report highlights the investment in a robust data analytics framework but overlooks the complexities involved in developing real-time capabilities. Real-time analytics requires not only advanced technology but also an understanding of the latency issues, data integration challenges, and the need for scalable solutions. Failing to address these complexities could hinder the effectiveness of monitoring AI resource consumption, making it crucial to consider them during the infrastructure development phase. 3. Bias and resource consumption metrics. While the report mentions data quality and bias, it does not delve into how biases in resource consumption metrics might affect decision-making. For example, if certain AI applications are overestimated in their resource efficiency due to biased measurements, organizations may allocate resources inadequately, leading to inefficiencies and inequitable outcomes. Addressing potential biases in how metrics are defined and measured is essential to ensure that the analytics derived from these metrics are trustworthy and actionable. 4. Ethical considerations beyond transparency. The importance of ethical considerations such as transparency and accountability is acknowledged, but the report does not discuss how these considerations will be operationalized within the metrics integration framework. Ethical AI practices require concrete mechanisms for accountability, such as audit trails and clear reporting lines, without specifying how these will be implemented. The initiative risks falling short of its ethical commitments. 5. Feedback loops and continuous improvement. The mention of feedback loops in the monitoring and optimization phase is significant, yet the report does not detail how feedback will be collected, analyzed, and acted upon. Continuous improvement requires a systematic approach to gathering insights from users and systems alike. Without a clear plan for how feedback will inform iterative development, there is a risk that the project may stagnate or fail to adapt to changing needs and environments. 6. Use case specificity. The report highlights industries where AI metrics will be applied, such as finance and healthcare, but it lacks specificity on how these metrics will be tailored to address the unique challenges within each sector. For instance, in healthcare, resource consumption metrics might need to consider patient outcomes and ethical implications of AI decisions. A more tailored approach could enhance the practical utility of the metrics and ensure they are aligned with industry-specific goals and regulations. 7. Investment breakdown and ROI expectations. While the report specifies a $1.8 million investment, it does not provide a breakdown of how this budget will be allocated across different phases or components of the project. Understanding the allocation of resources is crucial for stakeholders to assess the project's feasibility and potential for return on investment (ROI). Clear expectations on ROI, including how success will be measured, could foster greater buy-in from stakeholders and ensure accountability. 8. Training and capacity building. The report mentions training for personnel but does not detail how this training will be structured or what competencies will be prioritized. The effectiveness of the metrics depends heavily on the ability of personnel to interpret and act on the data collected. A robust training program that emphasizes both technical skills and an understanding of ethical implications will be vital for the initiative's success. Conclusion. The integration of AI resource consumption metrics is a forward-thinking initiative with the potential to enhance the efficiency and accountability of AI systems. However, the overlooked elements discussed above are crucial for ensuring that the project is not only successful in its technical implementation but also ethically sound and practically useful across diverse applications. Addressing these areas will require a commitment to inclusive stakeholder engagement, continuous improvement based on feedback, and a clear focus on ethical practices and real-world applicability. By paying attention to these nuanced aspects, organizations can better position themselves to leverage AI effectively while mitigating risks associated with bias, inefficiency, and ethical challenges. 1. Structured phases of development. The integration of AI resource consumption metrics is methodically divided into 4 phases: planning and requirement analysis, infrastructure development, implementation of metrics, and monitoring and optimization. This structured approach allows for thorough evaluation and systematic enhancement of AI systems, ensuring that each phase builds upon the previous one, ultimately leading to a more efficient and effective integration process. 2. Significant investment in data analytics. The allocation of $1.8 million for upgrading data analytics infrastructure highlights the critical need for robust systems that can handle real-time processing and analysis of AI resource metrics. This investment not only underscores the project's importance but also reflects a commitment to harnessing data analytics for improved AI resource management. The infrastructure includes essential hardware, software, and personnel training, which are vital for the successful implementation of the project. 3. Importance of data quality and addressing bias. Emphasizing the necessity of high-quality data and the mitigation of bias in AI systems is crucial for the credibility of the metrics being integrated. Reliable measurements of resource consumption are essential for ensuring that AI outputs are both equitable and trustworthy. Addressing these concerns will lead to more responsible AI applications across different sectors, reinforcing the need for ethical considerations in AI deployment. For practical applications and use cases, the integration of AI resource consumption metrics has significant implications for various industries such as finance, healthcare, and manufacturing. By tracking and optimizing resource utilization, organizations can improve predictive analytics, enhance decision-making processes, and boost operational efficiency. This practical application of metrics not only demonstrates the value of the initiative but also illustrates the potential for AI to drive innovation and performance across diverse fields. 1. The Manhattan Project, 1942 to 1946. This was a research and development project during World War II that produced the first nuclear weapons. It involved a significant investment of resources, both financial and human, and was structured into various phases, including the planning, development of the atomic bomb, and testing. Similar to the integration of AI resource consumption metrics, the Manhattan Project required extensive data analytics and resource management to ensure efficient operations and successful outcomes. 2. The Apollo Program, 1961 to 1972. NASA's Apollo program aimed to land humans on the Moon and bring them safely back to Earth. This ambitious initiative involved substantial investments in technology and infrastructure, with a phased approach to development, including the planning, spacecraft design, mission execution, and post-mission analysis. The program relied heavily on data analytics for trajectory calculations, resource consumption, and optimizing the spacecraft's performance, paralleling the strategic goals and the integration of AI resource metrics. 3. The Human Genome Project, 1990 to 2003. This international scientific research project aimed to map all the genes of the human species, which required extensive collaboration, funding, and technological development. The project was executed in phases, starting with mapping and sequencing, followed by data analysis and application of findings. The integration of various data resources and analytics infrastructure was crucial, much like the AI resource consumption metrics initiative, to ensure accuracy, efficiency, and the ethical use of genetic data. Future outlook: predictions for AI resource consumption metrics integration by Q2 2024 and beyond. As we look ahead to the integration of AI resource consumption metrics scheduled for completion by Q2 2024, several predictions can be made regarding the implications and advancements resulting from this initiative. The structured approach involving planning, infrastructure development, implementation, and continuous monitoring will undoubtedly shape the future landscape of AI resource management. Here are key predictions for the future. 1. Enhanced efficiency and cost savings. With a focused investment of $1.8 million in data analytics infrastructure, organizations are likely to realize significant efficiency gains in AI operations. By monitoring AI resource consumption metrics in real time, companies can optimize their resource allocation, leading to reduced operational costs and improved performance of AI systems. This predictive capability will allow businesses to avoid over-provisioning or underutilization of resources, resulting in a more sustainable approach to AI deployment. 2. Improved data quality and bias mitigation. The emphasis on data quality and bias in AI systems will likely lead to more robust algorithms and models. By systematically integrating metrics that track resource consumption, organizations can gain insights into data handling practices and their implications on model performance. This will pave the way for the development of frameworks aimed at minimizing bias, ensuring that AI outputs are equitable and reliable. As organizations adopt these practices, we can expect to see a shift towards greater accountability in AI applications across sectors. 3. Proliferation of use cases across industries. The successful implementation of AI resource consumption metrics will catalyze the proliferation of use cases across diverse industries. Sectors such as finance, healthcare, and manufacturing will increasingly leverage these metrics for predictive analytics, enabling smarter decision-making and operational efficiencies. As organizations witness the tangible benefits of integrated metrics, adoption rates will accelerate, leading to innovative applications that harness AI's full potential. 4. Development of regulatory frameworks. As AI technologies become more embedded in organizational processes, the need for a regulatory framework governing AI resource consumption will become more pressing. Stakeholders, including governments and industry leaders, will likely collaborate to create guidelines that ensure transparency and accountability in AI operations. Organizations that have established best practices around resource consumption metrics will be better positioned to comply with emerging regulations and standards. 5. Evolution of data analytics tools. The investment in data analytics infrastructure will fuel the evolution of more sophisticated tools tailored for monitoring AI resource consumption. We can expect advancements in analytics software, visualization tools, and machine learning frameworks that not only track resource utilization but also provide actionable insights for optimization. These tools will empower organizations to make data-driven decisions, enhancing the overall efficacy of AI systems. 6. Shift toward collaborative AI ecosystems. The integration of AI resource consumption metrics will encourage a shift towards collaborative AI ecosystems where organizations share best practices, tools, and insights. This collaboration can lead to the establishment of industry benchmarks for resource consumption, creating a competitive landscape that prioritizes efficiency and ethical considerations. As organizations learn from one another, the collective knowledge will drive innovation and improve the standards of AI deployment. 7. Increased focus on sustainability. As awareness of the environmental impact of AI grows, organizations will likely place greater emphasis on sustainability in their AI strategies. By monitoring resource consumption, companies can identify opportunities to reduce energy usage and minimize their carbon footprint. This focus on sustainable AI practices will not only align with corporate social responsibility goals but also resonate with consumers increasingly concerned about environmental issues. 8. Continuous adaptation and learning. The final phase of the integration process emphasizes continuous monitoring and optimization. As organizations gather more data on AI resource consumption, they will develop dynamic systems capable of adapting to changes in workload demands and resource availability. This adaptability will enable organizations to respond swiftly to market fluctuations and technological advancements, ensuring that their AI systems remain relevant and effective. Conclusion. The integration of AI resource consumption metrics by Q2 2024 represents a pivotal moment in the evolution of AI management. By investing in a structured approach to data analytics infrastructure, organizations will not only enhance their operational efficiencies but also address critical ethical and sustainability challenges associated with AI deployment. The predictions outlined above suggest a future where AI systems are not only more effective but also more responsible, paving the way for a new era of intelligent and equitable AI applications across various sectors. As we approach this milestone, the potential for transformative change in how AI resources are consumed and managed is immense, setting the stage for a smarter, more sustainable future.